Okay, hello everyone. I'm Cheng Xiao from this lab, master second year student. Today it's my pleasure to be here to present my research, the halation reduction system for high quality images of tomato fruits in greenhouse. This is my today's outline. In introduction part, I will talk about the machine vision system in agriculture, and also halation effects and its problem in greenhouse, and the objective of my research. Next, in materials and method, I will talk about the device and experimental setting, and the method, and also definition of halation in my research. Thirdly, I will talk about the results and discussion. I will talk about from the halation elimination effect, and also the color representation improvement. Finally, I will make a conclusion. Yes, this is the introduction part. Nowadays, machine vision system and also image processing are two important techniques for the precision agriculture. Farmers want to use machine vision monitoring system to obtain some information for plant health conditions, and also to support the decisions for plant cultivation. For machine vision system, illumination is one of the most important components, but it's difficult to control natural illumination, such as in the field or in greenhouse. It will cause a halation problem. This part is the halation effect. It's a kind of polarized light, which means we can remove it by polarized filter. It always appeared on glossy surface of fruits like the tomato. And it will lower down the image quality because the target will lose their color information. Actually, there is some research related with halation. In the open field, a specific angle of PI filter which minimizes the halation area can be calculated by time, latitude, and longitude. But in greenhouse, there is a multiple halation area problem. Because in greenhouse, the environment is much more complex. Sometimes not only the sunlight, but also some reflected light from the plastic wall or the metals will cause more than one halation area in one image. Look at this image. The blue part indicates that the halation area appeared on the tomato surface. So in this case, we can't use one rotational angle of PI filter to remove them all. So the objective of this research is to construct a halation reduction system to acquire high quality images of tomato fruits in greenhouse. This is a device I'm using to take images. This is a TV camera, and in front of the camera lens there is a PI filter attached with a blue gear. Above of the camera there is a stepping motor. A white gear is used to connect the stepping motor with the PI filter. So by this way, the PI filter can be precisely rotated 1 degree by 1 degree, so we can take the images with different rotational angle. And this is how I set my experiment. The place is in a greenhouse built by glass wall, and the camera is in front of the target, this tomato. The distance between camera and tomato is 300 millimeter. The tomato diameter is about 70 millimeter, and this is some setting of the camera. The shutter speed is 1/2000 seconds. The gain is from 150 to 180, correspond to different light intensity, and the F number is 1.3. By setting like this, this is a white balance adjustment. Take an image of the color checkboard, and in the area of the white part, the J value is about 180, and then we adjust the white balance to achieve this. Because we want to solve the multiple halation area problem. So in this experiment, one halation is caused by the sun, and this left part halation appeared on the tomato surface, and because of the reflected light from this mirror I set here, another right part halation can be observed on the surface. So by this, two halation areas occurred in these images. And in order to move all the halation, we use a combination of all the darkest point pixels method. First, we take images every 5 degrees from 0 degree to 180. Then we got 36 images. Some of the images may contain only halation 1, and some of the other only contains the halation 2. So we want to combine all of them. The combination method is, first we calculate the first pixels lighting density by this equation of each images. Then we can find the darkest pixel, which means the lowest lighting density. Then we can use this pixel as the first pixel of our result image. Then repeat the procedure until the last pixel, so we can get a result image, and the halation, all the halation part should be removed. Here is how I define the halation in my experiment. First, read the image with RGB value, and then normalize the image by this equation. Here we can get some normalized RGB value, and this is a normalized image. Then after getting this, we extract the halation area by this threshold. Here I use the normalized RGB and also the original R from the original image. Finally, I use a blue color to indicate the halation areas in the original image. Let's see the result and discussion. First, let's see the halation elimination. These three images is the original image with different rotational angle. The rotational angle is 75, 130, and 160, which correspond different condition. In this image, only the right part halation is still there, and this is the worst situation. Both of the halation is not be removed, and in this image, only the left part halation is still there. And this is our combined result image. So we count the halation pixel numbers in each images. In this one, the halation pixel number is about 4,000, and in this one it's about 6,200. And in this image, there are only about 1,300 pixels in the image. But in our result image, we can see there is only 730 halation pixels left. So, which means the combined result image can minimize the halation area in the whole image. But if we only focus on the tomato area, here the total number of the pixels of tomato area is about 10,000, and the halation pixels number in this image on the tomato surface is about 260, and in this worst situation it's about 1,600, and in this images there is only 81 halation pixels on the tomato surface, and in our result image there is no halation pixels detected in the on the tomato surface. So which means by this way all the halation is being eliminated on the tomato surface. Next, let's see the color representation improvement. Here, all the images is converted to the HSV model. Here is the range of the H value, S value, and V value. These two figures shows the relation between H and S, and correspond to these two images with on the tomato area in the tomato area. This is the worst situation, and the two halation there, and this is our result images. The y-axis is the saturation value. We can see in this original image, the tomato pixels, some of the tomato pixels, their S value is lower than 40 or even lower than 30, which means the color information is lost in these pixels. But in our result images, all the pixels of the tomato area, their S value is above 40. So we can say we can still read the color information from this image of the tomato. And if we focus on if we compare the standard derivation of the H value and the S value, we can say in our result image, the standard derivation is much lower than the standard derivation in the original image, which means the result image is the H value and S value became more consistent. It also indicates that our image color representation is improved. Okay, here is my conclusion. In this research, a halation reduction system with one stepping motor, one polarizing filter, and one PV camera was developed. And in order to eliminate multiple halation areas, a method is proposed. The tomato images are taken with different rotational angle of PI filter, then combine all the darkest pixels of all the images to get a result image. In result image, the multiple halation areas can be removed, and the H and S value of tomato area became more consistent. So this approach provided a good representation of tomato color. That's all. Thank you.
Question?
You have taken a number of images.
Yes.
Have you looked at how many images will be optimal? Is 6 images best, or?
Yes, actually, in some previous study, they pointed that maybe 3 degrees is the best rotational angle. In that case, all the halation area can be minimized. But in this experiment, just because our result image on the tomato surface, all the halation area is eliminated, so I didn't use 3 degree as a rotational angle step.
Anyone else? Your materials only red color fruits, only one fruit, or how many fruits?
Yes, actually I use different color with red and also some orange one. But maybe here in this time I didn't got some green one fruits. But for the red one and orange one, the effect, halation eliminated effect is all good.
How about the green one is also same definition, similar result?
Actually, actually, if we see this image, maybe this part there is a green color tomato, but on the surface there is a halation can be detected like this. Maybe definition of this halation method, this definition is good for the green one, but I didn't try if this whole method is good for green one or not.
You have to show those other conditions, other fruits result too.
Okay.
Then you just made the specific some condition.
Yes.
Sunlight and reflected light from inner.
Yes.
Maybe you have another condition, another reflected light or some secondary or tertiary reflected light condition or something like that.
Oh yes, actually maybe sometimes, like in this image, some reflected light is just from the back of the camera. In that case, maybe even how I rotate the PI filter, there are still some halation exists because of the incident angle is not the bruised angle. So in that case, maybe the result is not so good as this result.
So you have to explain what kind of condition that is tertiary light, tertiary light, or secondary light, or just transmitted light, or direct light, or some. Please make clear about that.
Okay.
Any other suggestion or question?
Okay.
When you use this method for tomato harvesting,
Yes.
which kind of operation is useful for this method?
Actually, in this case, we want to analyze the color information to get some high quality images contains all the color information of the tomato. Maybe it's not only for the harvesting, it also can be for some monitoring system. So after getting the whole color information of the tomato, we can know if the tomato is good or not, or some cultivation condition is good or not, like that.
Anything else? Cheng Xiao and Wang Tian are going to hopefully graduate from this school September. To do that, you have to do the defense August, early August, maybe. Not exactly, but we guess soon the deadline of the dissertation, draft dissertation, comes. I guess that dissertation deadline would be the end of next month. Before that, end of this month, you have to write a paper to some international journal. Okay. Then that is the first step. Then make a dissertation based on the paper and defense next month. That's a step. Maybe you have to you'd be required to make some kind of extended abstract for defense. That is a four-page abstract. The deadline also the end of next month.
Okay.
So you have many things to do. So step by step, we have to discuss, then go forward to reach the degree. Anything else? Okay, thank you very much.